Good. Here we go. So number one, I got negative 23 thirds for the x value. Number two, I got x is greater than 7, and the corresponding graph there next to it. Number three, I got y equals 5/6 x minus 2, and once again, a corresponding graph. Number four, I got positive 2, comma, negative 2 for my system solution. Got them all? Fantastic. Hey, maybe you got them all, but you have a question, or maybe you missed one of them. I don't know. It's always interesting to me, like, as we go through the week, I have this stuff where I say, hey, does anybody have any questions? I get a lot of, hey, I got them all right, and we're all feeling pretty good about this. And then when I grade your DMR quizzes on Friday, it's not straight hundreds, I'll tell you that. There are some hundreds for sure, but there's plenty of 50s and 75s and the occasional 25. And so I'm just wondering if there's anything I can say to you or show you right now that would help you, let's be honest, would help you tomorrow, right? Because that's what we're going to be working on, is that DMR quiz tomorrow. Sebastian, do you want to say something?
Well, just for number one, the numbers always seem to be that weird. Because, like, I thought I did it wrong when I got that.
Are you anti-fraction? You're anti-fraction, aren't you?
I guess. Well, because I got that same answer, but I thought it was wrong. So I just,
the numbers can kind of be whatever they're going to be. So yeah, I wouldn't look at that and say, oh my gosh, I must have done it wrong because it turned out to be a fraction.
yeah.
I would just go back through and ask myself, did I do those distributive properties right? Yep, check. Did I add things to both sides correctly? Yep, check. And if your answer is what it is, you're good. Here's something you could do if you've got the calculator with you. You could actually take that negative 23 thirds and you could plug it back in and check to see if you really do get a truth. That would be a way to actually check your answer. And the 23 thirds is a little bit awkward even to plug into the calculator, but you could do it. You could be for sure that it actually is that fraction answer. Yeah, that's a good question. Thanks, Ross. What else? Let's keep the conversation going. So let me come back at you with a question. Let's say, can we play a scenario out here? Let's say that you are this person. Let's say that throughout the week you get like 3 out of 4, 4 out of 4, 3 or 4 out of 4. Like, in other words, you're doing pretty decent, right? And then you get to the quiz on Friday and you get 1 out of 4 or 2 out of 4, something not as good as what you've been doing throughout the week. Let's say you were that person, or let's say you knew somebody like that. What advice would you give that person as to how they could better transfer those 3s and 4s out of 4s into Friday? What would you tell them, Greg?
Practice.
Practice. How would they need to practice? What would be a good way? At home. What would they practice with? Yeah.
DMR.
Yeah. I agree. So do you guys all know that these, did you guys know that these are posted on your Schoology? So you could actually download these or just bring these up on your computer, and it's blank.
Something like Greg.
It's just like that. It's totally blank, and you could say, all right, I'm going to do Unit 4, what would it be? Unit 4, Day 4 would have been the first one for this week. And you could try it. And the best part about that is if you have your packet with you, don't you have an answer key that you could turn to check your answers and say, hey, I got it right.
Mm-hmm.
And if Bray's idea wasn't good enough, you know what you could do? You could do Bray's idea again on the next day. And then you could do it again on the day after that. And it's actually, there's really no harm. There's actually a lot of benefit to practicing the same thing over and over and over again. Even if it is the same numbers and all that, getting that habit and seeing the connections is highly effective, believe it or not. Mason, what's up?
How did you get a positive slope on that?
Okay, good question. How did I get a positive slope? Let me do a little erasing here. I'm assuming that you subtracted 5x to the other side as your first step?
Yep.
Okay, so that would be negative 6y equals negative 5x plus 12.
Yeah.
Then did you divide by negative 6? Okay, so you divide by negative 6. So you get y equals, right here, what's a negative divided by a negative? That's it. So it'd be positive 5/6 x. And then, of course, a positive divided by negative is a negative, so it'd be a negative 2. But that negative over a negative for the 5 and the 6, that's where you get a positive slope. Thanks for asking. Anybody else? Okay, good deal. So guys, we're going to do a couple more days of more traditional instruction. Next week on Wednesday, we'll get back a little bit more into some of those Desmos activities. But if you would, flip over in your packet. Let's see how you do today. We might end up at the board towards the end. We'll just see how things are going for you. But if you could flip over into your packet and take a look at this. I want to see if you all can fill in the blank. I'm going to give you like 30 seconds to think this over. It says the primary concept is this. If you want to undo a square root, don't say anything, just write it. You think you know this. To undo a square root, blank the square root. So see if you can think of what should go in there. We'll double check it here in a second. Awesome. Oh, brutal. Okay. Anybody want to offer an answer? What do you think goes in the blank? What do you think, Ellie?
Square.
Oh my goodness, that's so awesome. That's exactly right. The way that you undo a square root is you square the square root. They're inverses. They cancel each other out. And that really, folks, honestly, that's going to be the big new concept for today. Other than perhaps this, I guess, these equations we're going to be looking at today are very interesting from this perspective. It is possible for you to do everything correct and get a solution and then find out that that solution doesn't actually work. So that's why I put up here, you need to double check your solution before you can say, I'm done. Especially with these kinds of equations, that's going to be quite important. So, if you would, see if you can take that idea that Ellie threw out there to you and try, number one, says solve, and then the equation is square root of x is equal to 4. So remember, this means to isolate the x, find the number that works.
Wait, so would you just go like that?
But whatever you do to one side of the equation,
Oh, so
you have to do the exact same thing to the other side of the equation.
x equals 6.
I'd say same thing, Chase. Whatever you do to one side of the equation, you have to do the same thing to the other side. And that's going to make this left side look a little different. How does a square root interact with a squared? They cancel. So I'm thinking, if you squared this, wouldn't that symbol bye-bye? Yes. Yes. Okay, cool. So I'll write this out here just so I have a little bit more room to work. Square root of x is equal to 4. If we're trying to get the x by itself, right now, it's obviously not by itself, right? The question is, how do you undo a square root? Well, the answer was just up there a second ago. What do you do to the square root?
Square it.
Square it. That's right. So what I would do is I would square the left side, square the right side. Look at your paper. Do you have any notation that looks kind of like that? As I walked around, there were a number of people that squared the left side, but not the right side, or squared the right side, but not the left side. If you have an equation to maintain balance, you have to do the same thing to both sides in order to maintain that balance. Now on the right side, hopefully you're all comfortable with the idea that 4 squared is 16. And on the left side, how would the square root and the squared interact with each other? They would completely cancel. And if the squared and the square root cancel, what are you left with? Just an x. And at this point, the x is by itself. You've isolated the x. So my proposed answer here would be 16. And this is a really easy one to check. You do need to check these. So I would check back in the original. I would write square root of 16 equals 4. And what's the square root of 16?
4.
If we know our perfect squares, we know that's 4 equals 4. That checks. Therefore, I can say with certainty that x equals 16 is my solution to this equation. So you want to check by just plugging back in. It's the same check that you've always done. Check it, though. All right. You guys ready to try number 2?
Yes.
Do it. Go. Try number 2, please. And if you do get done, and you're maybe done before I'm ready to start talking again, make sure you check your answer. How do you check your answer?
Oh, no, sorry.
Okay. Yes, ma'am. So you squared both sides. That looks good. Everything seems reasonable, but make sure you plug that in to check to make sure that it really does work.
Wait, what? But like, wouldn't? Oh,
What do you? But I'm confused about the plug-in part.
So take your proposed answer,
And then you
plug it back in right there.
But
Get
do you
like
keep the square
get
root?
rid of the squares. Yeah, you want to plug it back into the very original equation.
Oh, okay.
So plug it in right
it's
there.
It's like this.
Keep going now, Chase. That's a good first move.
So do I square 4x and?
No. So when you square the left side, you're squaring the whole left side, right?
Mm-hmm.
So again, how does the square root interact with the squared?
Okay.
They cancel out. So once they've canceled out, there's no more squareds to be had on that left side.
Yes.
Oh yeah, that does work. So
There you
it
go.
would be 40. The square root of 49 and then equals 7.
There you go. And so, yeah, that's the idea. Like when you get to the end and you feel like, I feel like I did all those steps right, that seemed okay,
Okay.
but I'm unsure of my answer, just
So
plug it back
when
in.
you're plugging in, you don't square it.
No,
Okay.
don't do that. You want to plug it into the most possible, like the most original possible expression you can. Noah, what's up?
I was just wondering if you could check.
Well, you should be able to check it. Oh, you checked it and you said it was good.
Yeah.
I think you've answered your own question.
I checked.
Right there.
I saw he checked it and everything. I mean, hard to argue with that.
Did he check it? Did he check it right there though?
Did he check it correctly, you're saying?
Like right there.
What do you mean, right there?
Never mind.
I don't know what you're getting at.
That's right there.
All right, here we go. So the
I don't know.
square root is already over there by itself. So the way that you're going to solve this is you're going to square both sides. And when you square both sides, on the right side you get 49. What happens on the left side between the square root and the squared? That's right, they're going to completely cancel out, leaving you with 4x plus 1. This hopefully will, for you, look like a really simplistic first semester equation now, right? We did these all throughout the first semester. I would go minus 1, that's right. I'd get 4x is equal to 48. And then how would I finish? So when I divide by 4, I come up with x equals 12. Mason, before I get your question, let me finish. I've got to check my answer. Here's how I check my answer. I select the original equation and I plug in. So it's just going to be square root of 4 times 12 plus 1 equals 7. PEMDAS tells me I've got to do the multiplication before I do the addition. So this would be square root of 48 plus 1 equals 7. This is starting to look pretty good because the square root of 49 is 7. That does check. Therefore, I can confirm that x equals 12 is indeed the answer. Your question? That's not correct.
I know. I didn't square it first. I subtracted one.
Oh, that's a problem. That's the. Hey guys, oh, this is so good. This is so good. Please, hey, don't zone out right now. Don't be distracted. You need to hear this. I'm going to erase all this stuff, and I want to focus. Mason has asked a really great question that I hope will be very explanatory and informative to you. So what Mason said he did is he subtracted 1 before he did anything else, and I want to illustrate what that would look like. Check this out. Here's my original equation, 4x plus 1 equals 7. And here's what Mason said he did. Now, Mason, you have to, please, for God's sake, watch this. Check this out. If I go minus 1 and minus 1. There's nothing inherently wrong with that, except, do you see how this is a radical and this is not? Those are unlike terms. I can't subtract the 1 from the radical and just sort of erase this out of there, because that's inside a square root, right? So those are unlike terms, and it's incorrect. And so I can't subtract that 1 out of there. There's nothing wrong with what I wrote in blue. I just can't really do anything with it. And so once you get that radical all by itself, the very next thing you need to do is square root both sides to get rid of the radical. And then you can get into the whole, how do I deal with the 1 and the 4 and all that stuff. Does that make sense? You guys are going to be tempted to do the same thing that he was asking about. You will be, I promise. Okay. Any follow-ups on 2? All right, I'm going to give you guys a little bit of guidance on 3, and then I am going to let you try to finish 3. Listen, please. Listen. Don't just launch off into this. Hey, stop writing. I know that sounds weird for me to say stop working, but please stop working. Stop writing. Do you all see, and this is going to go right to Mason's question, do you guys see how the 10 is inside the radical? At the same time, do you see how the plus 6 is not?
Oh, that's true.
Wait, so are they like
It's true right there.
So yeah, the square root of x minus 10 and the plus 6 are unlike terms. They can't be combined. So my first move here, believe it or not, is this. I'm going to subtract 6 from both sides. I can do this because the 6 is not in the radical. So I can just subtract them. And I need to do that. And now we have like terms that can be subtracted and we're good. Yeah. So it's going to be square root of x minus 10 equals negative 4. Now I want you guys to try to take it home from there. Okay? Sir.
Could you do it so that you square first and then...
That would make a mess.
Really?
I would not do that. Yeah, so if you try to do that, you're actually going to be getting into multiplication that you've never done before. Yeah, that's not correct.
Okay, cool.
So believe it or not, I'm not going to write this on the screen. I'll write this on this. So look at what you did here. You squared one part of the left side,
Yeah.
ignored that part,
Oh, okay.
right?
I understand.
So here's what would happen. Like if I have square root of x minus 10
Yeah.
plus 6 equals 2, and I square this side, what I would have to do is square this entire left side.
Okay.
Now, the right side is super easy. The left side is a big mess.
Yes.
When you square something, doesn't squaring means you multiply it by itself? So here's what the left side would really look like. It's the square root of x minus 10 plus 6 times the square root of x minus 10 plus 6.
Okay. Yeah.
Which ends up being x minus 10 plus 12 square root of x minus 10 plus 36 equals 2. You see how you've made a far bigger mess. So we're going to get into why this is that. We'll get into that later this semester. But you want to get that radical by itself and then square both sides.
Okay, cool. Where'd you get?
All right, Ellie. Ella. Don't ask me if you have the right answer because you should be checking.
But we were checking it and we noticed that.
root of 16 is 4, not negative 4, so does that mean
So what do you think? So one of two things has happened. Either you've made an error somewhere, or that answer doesn't work. It's one of those two. So I'll give you guys a moment to think it through. Go back and check your work. Like this would be
It was a negative here.
this would be a good time for you guys to go back and double check your work and just like try to decide, did we make a mistake or did we make no mistakes and maybe this answer just doesn't work? Because remember I told you that's possible. It's possible to do everything right and just have the solution not even work. It's possible. So double check your work and see which case you think it is. Okay, work together. You guys are doing a great job.
Minus 6.
Okay, so hello Oliver. So let's talk, buddy. This is actually exactly what Mason was talking about a second ago. You have square root of x minus 10 equals negative 4. And you have added 10 to both sides. Now there's a big problem with that because that number in there is not a 10. It's a square root. of 10. So for me to go plus 10 and plus 10, that's no big deal for the right side. It just gets you a 6. But these two cannot be combined.
Maybe we made
They're
it.
on their terms. This is the square root of something, and this is a non-square root.
Okay,
You
26.
cannot add a square root with a non-square root. So when you get here, like this step is fine. Once that radical is by itself, how do you get rid of a radical? How do you get rid of a square root?
Wait, was it
Square it. That's what you need to do. Okay? Hey guys, let's check out this answer. This is where I left you off. Hey guys, please focus here. You've had like 5-6 minutes to be working on your own, maybe slightly unfocused. Now is the time when you refocus, right? Let's compare and see how this went. So that's where I left you. The square root is all by itself. So your next step would be to square both sides. Once that square root is all alone, you square both sides. And so that's what that looks like. The right side, what's -4 in the parentheses squared? It's positive, right? Because it's -4 times -4. So it's positive 16. The left side, what happens with the square root and the squared?
It crosses itself.
Yeah, they cancel each other out, right? They're crossed out. So I get x minus 10. What's my final step?
Add 10.
So when I add 10, I get x is equal to 26. So, guys, listen, I've been consistent about this. Every single time I do these, I'm going to check my answer because it's possible to do these perfectly, do everything right, and get an answer, get a solution that doesn't work. So let's check. So if I check this, I check it off my original, I get square root of 26 minus 10 plus 6 equals 2. This is 16. Oops. There we go. So that's 16 right there. Am I doing this right? Yeah. So this is 4 plus 6 equals 2. And this is where this gets weird. 10 equals 2?
No.
You guys subtracted the 6 over. That's your issue. That's why yours looks a little different than mine. I'm not really concerned about that. So this is where I pause and I think, whoa, wait a minute. 10 definitely does not equal 2. Like this much is clear. So when I get to something like this, I got to think, well, man, maybe I messed up. Maybe I added wrong, subtracted wrong, multiplied wrong. Maybe I did something wrong. If I go back through here and look at my work, I actually end up thinking, I don't think I did anything wrong. I subtracted 6 from both sides. I did that correctly. I squared both sides. I did that correctly. I added 10 to both sides. I did that correctly. So I'm feeling really good that this 26, like no mistakes were made to get to that 26. Yet when I check it, it doesn't work. So here's what that means. This is what's called an extraneous, that's a big word, extraneous solution, which means that it's something that appears to be a solution but doesn't work, meaning it's not a solution. So let me just pose this question to you. If I came up with one possible solution and I just proved that it does not work, what's my final conclusion? There is no solution. So this is my final conclusion, that the only number that might have worked didn't work. So since my only possible answer didn't work, there is no answer. There's no solution.
Don't match, it's no solution.
Say again?
Like if those two don't match, then
Yeah.
it's
If you did everything right and you get 10 equals 2, that means there's no solution.
Wait, but why, when you were checking it, why didn't you subtract the 6 first, but we did for like the very
Does that make any difference?
Yeah.
No, it doesn't. If I if I did
Oh, it's
this,
because we know what x is.
if I did this, I get 4 equals -4. That's still false.
Oh, and that's like what we basically.
That's exactly what you got. You can rearrange this however you want, but you're going to still get a false every time.
Oh, okay.
Yeah. Yep. Hey, do you guys see the point now in checking?
Yeah.
Got to check to be sure. Okay, I think there's maybe 1 or 2 left. Yeah, it looks like there's 2 left. So let's try them. Let's try number 4.
Mr. Anderson, can I run to the restroom?
Of course. Ooh, number 4 is a dandy.
So,
Love it. Okay, you should be working on number 4. Number 4 has 2 square roots. Oh my goodness.
What the?
What in the world?
I don't even know where to start. I want to cry.
Wait.
Oh.
What do you think?
Do I just square both sides?
Well, I can tell you this for certain, Sebastian. I can tell you this for sure. If you square one side, don't you have to square the other side?
Yes.
So at least what you said was logical, right?
Yeah. Wait, but can you distribute into it? No, you
So
can't distribute
remember how
into a radical.
hang on. Remember how when we talked yesterday about multiplying in these situations, you can multiply a radical times a radical, no problem.
Yeah.
You can multiply a non-radical times a non-radical, but you can't really multiply a radical times a non-radical.
Yeah.
So I'm overstating it a little bit. You actually sort of kind of can, but it makes it way more complicated than we want it to be. So I would just say, like, don't try that.
Okay.
I would actually go with your idea.
Square.
Why don't we just see what happens when we square both sides?
But do. Okay.
Both sides, not select pieces of both sides, but both sides in their entirety.
Would the 4 get squared?
Yeah, so I'd put parentheses in there just to make sure you did that right.
Wait.
Because the 4 is, of course, part of the right side. So if you're going to square the right side, it gets squared too.
63 minus x equals 16 x plus 5.
And I would put parentheses around the x plus 5. I would put parentheses around the x plus 5.
Wait, why?
Oh, and then, okay.
Well, so should, like, x plus 5, isn't x plus 5 the same as 5 plus x?
Yeah.
So the order shouldn't matter, right? So if you write it the way you wrote it, it's 16 times x. But if I decide to write it as 5 plus x, now I get a totally different answer, right? And so what you're actually doing is you're multiplying the 16 times the whole x plus 5. Not just the first term you come to. It's the whole thing. Right? Because you can see it's 4 times the whole radical, right?
Yeah, oh, that's okay. That's,
So it'd have to be 16 times the result.
yeah. What's 16 times 5?
16 times 5 is 80.
So
Sure.
80,
16 times 5 is 80.
Okay.
63. Wait, hold on. Would this be 17 or negative 17 or negative 16?
17?
Well, because-
if you subtracted,
Yeah.
make sure you subtract it from both sides, not just the right side.
Oh, yeah. Okay.
So negative x. So basically what you have there is you've got negative 1
X.
plus negative 16.
Okay.
So that means
it's
left
negative
1,
17.
left 16 is negative
Okay,
17.
thank you. Equals 80.
This is good. Okay, how you guys doing? So Issa, you have done excellent work with one exception. I like the idea here that you squared both sides right away. It's the right move. The only thing I see here is you kind of unincluded the 4. So you squared the whole left side, that's perfect. You didn't really square the whole right side. You just squared part of it. You need to square each of the factors on that right side. So I would just move your parentheses right there. And that's going to change that 4 to something different. What's up, Sophia? I'm just looking at this first step. You tried something very well.
That's what I'm talking about.
That first step looks good. Well, I don't know if your other steps are good, but
But I just don't know how to check.
you don't know how to what?
I don't know how I would check.
Take this and plug it back into the
Yeah,
original.
but I don't know how to check that.
I'll show you. Yeah.
So the 4 is not a radical for this.
Right.
So if you divide by
This
4,
overcomplicates. Oh man. When you square both sides, though, isn't 4 squared 16?
right here, right here.
You squared the left side.
Might be able to do it like.
But the 4 is in a radical, so you can't square that.
Sure you can. If you square the whole left side,
So then why wouldn't you just square it here?
that's what I
No,
would
you
have
could
done.
maybe
I don't
do it like right here or something.
It doesn't matter because it's 4 times the square.
It's 4 times, not 4
The
plus.
square doesn't have anything to do with it.
Oh, I think you're thinking 4 plus. That would make a big difference. If it instead of see how it's 4 times. If it was 4 plus the radical, that'd be something else entirely.
Technically it's touching and it's kind of, I don't know.
I'm not sure. What do you mean by touching?
Like it's the same. It's like,
It's the same term.
yeah.
Yeah, I agree.
Wait, is this right?
Have you checked it yet?
No, okay.
Could you rewrite this to be 4 times the square root of x?
That's exactly what it is. Yep, that's exactly what it is. Yes, ma'am.
What did you guys think about that?
Okay, is it an answer check?
So I solved it.
Your first step looks great.
I don't.
I'm just looking at your first step right here.
Okay, so I solved it. This is my answer. Should I use like the factor tree?
Oh, be careful, be careful, be careful. It's -1 you got for an answer, isn't it? Looks to me like you plugged in a +1. You need to plug in a -1 to check. That's probably it. Can I show everybody? And I'll pick up your question. Hey, guys, here we go. Walking around, your guys' instincts are starting to get pretty good. A lot of folks, their first move was this, where they squared both sides. This is a very good instinct. This is the right move here. So when you square both sides, the left side is the easier of the two. It would just be 63 minus x, right? Because the squared and the square root would cancel out. The right side's a little tougher. The 4 needs to be squared. That's right, but it needs to be squared as well, doesn't it? So it'd be 16. And then, of course, the square root of x plus 5 squared, the square root and the squared cancel out. So you end up with parentheses
16x plus 5.
Parentheses x plus 5, right? Yep, and the next step is going to be a distributive property. So it'd be 63 minus x equals 16x plus 80. I would maybe add x to both sides. So here I'm going to get 63 equals 17x plus 80. It's not looking good because the numbers seem weird, but doesn't it come together pretty nicely at the end? I'm going to subtract the 80. This gives me negative 17x, negative 17 equals 17x. And this is where it turns out pretty nice as far as the numbers go. Sebastian, I'm sure you're happy about this.
Oh, yeah. I got the same answer.
X equals -1. Yay, it's not some crazy fraction.
Let's go, Sebastian.
Okay. Now, hey, you guys found out in number 3 that sometimes it's possible to do everything right and get one of those extraneous false solutions. So I'm going to come over here and check my answer. I'm going to just check it in the original, so watch this, see how this goes. It'd be square root of 63 minus -1 equals 4 times the square root of -1 plus 5. What's 63 minus -1, really? And therefore it'd be 64. So square root of 64 equals 4 times the square root of 4. What's the square root of 64?
8.
And what's the square root of 4?
2.
Times 4 is? Look at that. It checked. Therefore, I am feeling like this is a happy answer. Okay. We're going to do one more together, and it's going to look like the scariest one, but you're going to find pretty quickly it's not. Y'all ready to finish? Okay. Hey, don't forget that tomorrow we have our Concept Quiz 12. Concept Quiz 12 is on adding and subtracting and multiplying radicals. Yes, adding like radicals, multiplying radicals, that sort of thing. So, hey, listen. Kind of long. Remember when I was quizzing Bray earlier about, hey, Bray, what if somebody wasn't doing very good on their DMR quiz? What could they do?
Practice your concept.
So I would say for the concept quiz, it's the same thing. If you wanted to do great on your first try in your concept quiz, I feel like you should go back to what it would be Tuesdays and Wednesdays days in the notes, those pages in the notes, and practice and practice and practice until you feel super solid. That'll help. I don't think it's going to hurt anything. I think it'll help. This last one looks a little scary. Please watch and go do this with me. Do you see how the radical is by itself right now?
Mm-hmm.
It's kind of a scary looking radical, but it is by itself. Whenever the radical is by itself, what should be our move? Square both sides. There you go. So I square the left side. and I square the whole right side. What happens on the right side?
The square root goes away.
They cancel. Square root goes away. Yeah, square root and squared cancel each other out. So I get x squared plus 9x minus 45. What happens on the left side?
The x squared.
It's just x squared, right? X squared is x squared.
Next is second.
Okay, so now I'm going to try to solve this. Do you guys see any simplifying I could do, Julia? No? Do you see any simplifying I could do before I get
Oh,
going?
wait, no.
There's something.
Well, you could, but they're not on the same side of the equation, so you'd have to move it.
What do I need to move?
The x squared.
Do you see how there's an x squared on both sides?
Well, that's not.
Oh.
So what I'm going to do is I'm going to subtract x squared. This is where people will do some kind of silly stuff. What's x squared minus x squared? It's 0. So I would get 0 equals 9x minus 45, and hopefully... Oh, hang on. Hang on. I was about to say...
I'm so sorry.
Listen, I was about to say, this is where people will see that... This is where people see that 0 and they freak out a little bit and they think, oh my gosh, the 0 is a massive problem. It's not. What do we do? Plus 45. And this is obviously a very easy addition with 0. You get 45 is equal to 9x. Dividing by 9 now. It actually, again, for Sebastian's comfort, x equals 5. A nice integer answer.
See that?
Let's go.
All right, we're out of time. You would want to check that answer. Let's see here. It works out nicely. It does check. It does work out just fine. So, hey, I'll see you guys tomorrow. We're going to keep practicing with these tomorrow. So, hope you have a good rest of your day.
Oh, yeah? Sure. No, I won't be.